Alright, so we're going to be looking at probability now that is experimental probability. So no longer from theory based on what we know just in a perfect world, but experimental probability, which is usually calculated either from observations or from running an experiment. And what we're going to look at is also using the terms relative frequency. And this is basically a calculated proportion or probability from a collected data set. So if we have a relative frequency, that means like if I collected a whole bunch of marbles, I could give you a relative frequency, which is kind of like a probability based on what's in my collection. In the long run, relative frequency is basically just doing it for a really long time or collecting a lot of data and then calculating your proportion, which is basically going to give us an equivalent probability. And one thing to keep in mind is that the more trials, or the longer the observation, the more reliable the long-run frequency will be when you're calculating your probability. So more is better in this case. And in a lot of situations, the data will be given to us in a table. So given a table of data which compares groups, we can calculate our probabilities from the relative frequency. And again, this is still basically just the same thing we've been talking about. The number of desired events or desired outcomes over the total possible. So I am saying total here, and that's really important for us. In tables, make sure you calculate your totals. So if you don't have one, add the total column, because we'll need to know what the totals, what all these add up to. And what I mean by that is in this table, I'm looking at the number of students who are in different year levels, year 9, year 10, and year 11. And I've been given information about what co-curricular activities they're involved in. So for instance, there's 170 year 9 students that do drama. Well, if I wanted to know how many total students do drama, I need to add all these numbers up. So 170 plus 165 plus 150. And we get a total, if you put it into your calculator, of 485. Sorry, not a lot of room there. And same, my total number of students who are doing chess, 54 plus 32 plus 24, gives me 110. And the number of students playing sport, 94 plus 85 plus 62, gives me 241. Now I'm going to add all of those up to get a grand total, and that's going to be 830. So in total here, I'm looking at 830 students all up. 485 are doing drama, 110 in chess, 241 in sports. And now I need to know my totals by year level. So how many year 9 students are there total? Again, I would add all these numbers up. And if you put them into your calculator, you get 318. In the next column for year 10s, total of 282 students. And for year 11s, 150 plus 24 plus 62 is going to get us 236. And again, if I add all of those up, I should also get 830 total. So if you're not given your totals on a table, you need to find them before you can really calculate anything. So now that we know the total number of students and the total number of year 9s, for instance, or year 10s, we can calculate probabilities a lot easier. So from the table, we need to find the probability of the randomly chosen student. So basically, if we put all of those students into a bag and shuffled them up and reached in randomly to grab one, what's the probability that I'm going to get a student who's taking drama? So again, how many total students are taking drama? Here I found out by adding those three numbers together. I had 485 total taking drama out of 830. So again, the number that I want, the desired number in drama, of 485 out of the total 830. And if it's a big ugly number like that and you don't want to simplify the fraction, it's a good idea to put it into your calculator and get it as a decimal. Remember, your F to D button will do that on your calculators, but that's going to be roughly 0.5843. And I'm not going to put it as a percentage, I'll leave it as a decimal. So again, 485 total taking drama out of the 830. Part B, in year 11, so the student, we're looking for a random student if they're in year 11 and taking chess. So I need to look at which of these students is both in year 11 and taking chess. And I can see here that there's 24 students total that are taking chess that are in year 11. So that's 24 out of the 830 total. Because I don't know for sure whether they are in year 11 or that they're taking chess. I just know that I want one student who's both in year 11 and doing chess. And 24 divided by 830 gets us 0.0289 roughly. So part C, we're looking for a student in year 9, so someone in year 9, and not taking sports. Okay. So in year 9 and not taking sports, that means they must be doing chess or drama, but they're not doing sport. So here, I'm going to have 54 plus 170. So 54 plus 170 gets you 224 out of the 830 students total. And if we put that into a calculator, you should get 0.2699. Sorry, messy. 699. So again, that's year 9 students that are not doing sports. So that gives me the ones in drama and the ones in chess. Last question here. We're looking for a student in year 9 or in year 10 that's doing sport. So students in year 9 that are doing sport, down here, or students in year 10 that are doing sport, those ones as well. So I'm going to add those two numbers together. You can write that out if you want. 94 plus 85 out of the 830 total. So 94 plus 85. That gets me 179 students out of the 830, which as a decimal is 0.2157. So it's still the same idea. Look for the desired outcomes, the students that you actually want, and out of how many total.